Yesterday, we talked about the two main types of data, quantitative data and categorical data. Remember, quantitative data is data that are represented by numbers, something that we can find the average of. Categorical data are categories, so things that they may contain some numbers, but they could also contain letters or words. So, for example, could be cell phone ownership, yes or no. Okay, those aren't quantities. You can't average them. That's categorical data. So for the next couple of lessons, we're going to focus on categorical data and how we analyze it. Then we're going to move over to quantitative data because we actually do that the most. Okay. And the best way to do it is sort of by an example. There is a program in New York called Stop and Frisk. And it allows the police to stop people on the street and search them for weapons or drugs. No, like they can just say, no, stop. We want to frisk you. Yes. Yeah, it was actually deemed unconstitutional 10 years ago, but it's still going on today. Very controversial program. Okay. Because because many people feel it's a violation of one's rights, that they can just be stopped out of the blue for no reason whatsoever. Okay. And also, there's been issues with the ethnicity of people that are being stopped that we'll talk about a little bit later on. Okay. And so here, from 2020, here is data on 4 ethnicity groups, how many were stopped, whether they were found with weapons or drugs, and a crime was reported, yes or no, okay? And what we do with this type of categorical data, because remember, the categories are race, which is categorical, okay? They're words. And whether police found and reported a criminal offense. Found and reported criminal, yeah, that doesn't make sense, offense. And so there are numbers that are involved with the categories, like we want to find out how many were, yes, how many were not, and in what ethnicities, how many were stopped, and how many were found to have committed an offense, and how many were not. And the best way to sort of show and analyze categorical data, or yeah, it's pretty much the best way, is by a two-way table. So a two-way table is a bunch of counts, is a table of counts describing two categorical data sets. And what are the two variables described in this table? Well, race or ethnicity. Sorry, race and whether a criminal offense was reported, meaning that they found weapons or drugs on the person and were able to charge them. And we can, if it's given in this form, we can answer all sorts of questions from it. Okay? Such as the following questions. Except what we're going to do to answer these questions is we're going to have to add some information, because it says what proportion of the sample were stopped by police? Doesn't that mean that we need the total that were stopped by police? Okay, as well as the grand total of those who were stopped and who were not stopped. So when you see a two-way table, one of the things that you're going to have to add are totals in order to analyze. And then this here, once we get it, would be the grand total or the sample total. These would what we were call margin totals. So if we total these up, and I'm just going to give them to you, save a little bit of time. If we total the number that were stopped from all four ethnic groups, we get 3684 that were stopped and found to have reported or found to have committed a criminal offense. Ones that were not, that were stopped but were not found, 5,637. The total number of Asians that were stopped, 219. Total number of black civilians that were stopped, 6,196. You can possibly see where this is going. Hispanic people, 2,050. And white people, 856. For a grand total, and you can either add these four or these two, it's still going to give you the same grand total. 9,321 people were stopped. Anything kind of jump out at you right away? Yeah. Like just by looking at the table, we don't even have to look at any graphs of it. It's like, wow, there was a lot of black people that were stopped out of the total number of people that were stopped. Anyway, so let's answer some questions now that we know this. What proportion of the sample or the grand total were stopped by police? How would we find that? How many were stopped? No? Or sorry, what proportion of the sample were stopped by police? Wait a minute. I don't think that question makes sense. I know it doesn't make sense, so I need to change. You're right. I need to change this question. What proportion of the sample were stopped by police and a criminal offense was reported? That's what it should say. That's what I wanted to get to. 3,684 out of the entire sample of 9,321. Now, you could see two different words that you're asked, proportion or percent. If you see the word proportion, that means you should be leaving your answer as a fraction or decimal. If you see the word percent, then you've got to convert that to a percent. So we could leave our answer like this. There's no penalty for not reducing fractions. So we have no idea whether this could be reduced or not. These are awfully big numbers, but it doesn't matter. Okay. So if we decided to go to decimal, then we would get approximately 0.395. Okay. what percent of the sample were Hispanic? We got to change this one again. Were Hispanic and stopped by police, but no criminal offense reported. So how many were Hispanic and they were stopped, but no criminal offense was reported? Out of the entire sample of 9,321. This one we have to go to percent. So just divide times by 100. Usually when we answer in percent, we usually answer to one decimal place. So you should get approximately 13.2%. Okay. It's out of the grand total because it says what percent of the sample. Okay. But yes, you've got to be careful how you read this. Because this last one, what percent of those stopped by police and a crime reported were white? So how many were stopped by police and a crime was reported? Note the total. How many were stopped by police? That's how many of those. Hang on. It says, what percent of those stopped by police and a crime reported? So the bottom fraction, the bottom part of the fraction is going to be the total that were stopped by police and a crime reported. 3,684. Of those, how many were white? That's our numerator, 352. And then we convert that to percent and we get approximately 9.6%. So you've got to be able to read the questions carefully, because sometimes the denominator, if it says percent of the sample or percent of all sampled or percent of the grand total, then you have to go to the grand total here as your denominator. Okay? So this represents the grand total. Sometimes the denominator will be your margin totals. Okay? So these we call margin totals because they're on the margins. So that last one was a margin total one, whereas the first two were grand total ones or sample total. And then we would just call these things in here, I just call them, because it's the intersection of two categorical variables, I just call them cell values. Sometimes you may be asked to report an entire distribution of one of the categorical variables. Okay? Such as marginal distributions. Marginal distributions will always be this. This is how you calculate them. It will always be one of the margin totals, or one or more of the margin totals, over the grand total. Marginal distributions will always be that. The margins are the numerators. The grand total is the denominator. So you are asked to find the racial distributions of civilians stopped by police. Yeah, I'm gonna have to change all these. And offense reported. So what we want to find is the race, the percentage of race, the percentage of each race that was stopped by police and an offense was committed. Okay, so we want to find the Asians, Black, Hispanic, and white. And remember, these ones are the totals. So they're all going to be over the grand total. So how many were stopped and an offense reported out of the grand total of 9321? How many were Asian? 77. How many were Black? 2431. 824 were Hispanic. 352 were white. And let's convert all these to percents. And we would get approximately 2.3% were stopped, found to have committed offense were Asian. 66.5% of Blacks who were stopped were found to have committed an offense. 22% of Hispanics that were stopped were found to have committed an offense. And 9.2% of white people that were stopped were found to have committed an offense. So this kind of tells us right away that, wow, looks like most people that commit offenses are Black people. But is that the case? Okay, we need to further study this. We need to look at it further. So what we're going to do is we're going to take these and we're going to put it on a bar graph, which is here below. Okay, we've just taken these and put it on a bar graph. But we've added another bar graph. This is the percent that each race represents the population of New York City. So these two bar graphs side by side, we obviously call them a side-by-side bar graph. Okay? This kind of tells us a bit of a different story once we see this graph. Okay? So what do you notice? What do you wonder? Well, an awful lot of stops and crimes reported were Black people, and yet they only represent a quarter of the population of New York City. And yet whites people represent almost a third of the population of New York City, yet they were only found to have committed offenses 9% of the time. Okay? Something seems off here. Or it's just that, I mean, there's a lot of black people that commit crimes, which is very suspicious in itself. Okay? So what do we see from here? Well, we see that police tend to stop black civilians. At a disproportionately high rate compared to the percentage of people no, I don't. I'm sorry. I don't like this. This is not. No. Police tend to stop black civilians at a disproportionate compared to this. Stop and charge. Thank you. Police tend to stop and charge. I'll say black civilians at a disproportionately high rate compared to the percentage of black civilians that live in New York City. That's really the big thing that jumps out. Okay. The percentage rates of the three other races stopped and charged. The three other races stopped and charged. Are lower than their representation. So it's still kind of, the question is out here, is like, so do black civilians commit the majority of crimes? Well, they certainly seem to commit more than how much they represent the population of New York City. So perhaps we need to study this even further and go to something called conditional distributions. And the mayor at the time that stop and frisk, or the mayor who defended stop and frisk, I think this was 2015. Oh yeah, 2015 it says. This is what he said about it. He said, people say, oh my God, you're arresting kids for marijuana who are all minorities. Yes, that's true. Why? Because we put all the cops in the minority neighborhoods. Yes, that's true too. Why'd we do it? Because that's where all the crime is. Okay? Again, kind of an inflammatory statement. Something that other people that advocate for stop and frisk still make similar claims, but is it supported by the data? Okay, so what we're going to do is we're going to look at some conditional distributions. And when we do conditional distributions, it's always the cell values over the margin totals. So we want to calculate the crime rates among each racial group. So what that means is we want to say, okay, for the Asian population, how many had committed a crime out of the total number of Asians? Well, how many were found to have committed a crime or were charged? How'd you get that? No, because that's not the same. That's not quite the same thing. Okay, because I never said over the grand total. What percent of the Asians were stopped and charged? How many Asians were stopped and charged? 77. Out of how many Asians in total that were part of the sample? 219, which actually does work out to 35.2%. Black people, well, how many were charged? 2,431 out of how many black people in the sample? 6,196 gives us 39.2%. Very similar to Asian. All of a sudden, that previous data that we have is looking a little fishy. Hispanic, well, 824 were charged, stopped and charged. Out of 2,050 Hispanics in the sample, 40.2%, higher than the black civilians. And about of all the white people that were stopped, 352 out of the 856 white people that were stopped were found to have committed some offense, which represents 41.1%. The highest percentage out of all four. So this kind of tells a different story. It all depends on what you analyze. Okay? Like if we just looked at the marginal distributions, we saw that, wow, like black people committed the majority or were charged in the majority of the time, like a big 2/3 of the time, even though they only represented a quarter of the population. Okay? And yet, when we analyze each each racial group, we see that, well, out of all the black people that were stopped, only 39.2% were charged, but yet out of all the white people that were stopped, 41.1% were charged. And we can show this, and often categorical data is shown on a bar graph. So we're going to sketch a bar graph. You should be familiar with that. So what is involved in a bar graph? We need a title. So reported crime rates among racial groups. You need a title. Okay. Title. You need labels on each of the axes. Okay. The only scale in a bar graph, because it's categorical data, there's going to be no scale on the bottom. The bottom is just going to represent the races, the bars. Okay, so all we have to do on the bottom is we just put race as our label, and then we list the 4 races. Asian, so Asian, Black, Hispanic, I'll just put HISP for short, and white. And then here would be the percent where a crime was reported. And that would go from 0 to 100. So let's just put our notches up by 10, 10, 20, 30, 40, 50, 60, 70, 80, 90. I'll go up a little bit, 100. So 20, 40, 60, 80, 100. You need your labels. Okay. So now we're going to put our bars. So Asian people that were stopped committed 35.2% of the time. So probably somewhere around there. Black people were 39.2% of the time, so it's going to be just under 40. 40.2 for Hispanics, so it's going to be just over 40. And 41.1% for white, it's going to be above the Hispanic. Now that would be a bar graph showing, and I'm just going to do this. Okay. So this would be a simple bar graph showing the reported crime rates among racial groups. We could also do a segmented bar graph. A segmented bar graph, each of the bars must go up to 100. So they're all going to look like this. They're all going to go up to 100 from their bars. Oop, that was brutal. And this gives us an idea of the percent for each race where a crime was reported and where a crime wasn't reported. So we would need, if we do a segmented bar graph, which is what this is called, we would need a little key here. Like this represents crime, I'll just put, whereas this represents no crime. I just want to show you sort of what the different bar graphs look like. There's a simple bar graph, segmented bar graph, the bars will always go up to 100% and they'll be split in different colors or different styles, okay? And then you'll need a key. And then the side-by-side bar graph you saw on the previous page. So you should be familiar with marginal distributions, where the denominator is the grand total and the numerators are the margin totals. You should be familiar with conditional distributions, where the numerator is the cell values and the denominator is the margin totals. And you should be familiar with the graphs. Really often you are not asked to create a graph, okay? For the most part, you're analyzing them. Okay, so what do we get out of this? We need to see if there's some kind of an association. Does knowing the value of one variable help us predict the value of another? In other words, in this specific example, does knowing one race predict crime rates? When you describe an association, first thing you want to do is make a claim. There is or there is not an association. You may even want to throw in words like slight in there, if it's close. You want to support your claim. By comparing percents between each group. And finally, include context. And what I mean by context is refer to the actual problem. Don't say, this is what I mean. This is something that is not in context. There is an association between this and that. What's this? And what's that? You haven't spoken in context. You haven't spoken about the specific problem. That's what I mean by context. Don't use words like this or that or it. So in this example, we would say, there seems to be a slight association between races and criminal activity. So I've made my claim. Or race and crime rates. So now let's support the claim by comparing percents. Well, what race had the highest percentage of charges? White people. So we would say police discovered higher crime rates, not a huge amount higher, but higher, among white people. And that was 41.1% than the three other races. So what does this suggest? What does this association should suggest? Well, chances are of those who are stopped, if they're white, they're more likely to have committed a crime. Okay? So that quote from the mayor at the time, is that quote supported by what we just did? No, it's not. Okay? So, no. Way more Black people were stopped. Than the percent of Black people that committed a crime. Right. Way more black people were stopped and charged. Remember, that was like 66%. Then the percent of black people that how do I say this? Way more black people were stopped than charged. Out of the sample, than the percent of black people that were stopped and charged. Yes, you could say that too. Absolutely. Yeah. That might even be a better answer, probably. Okay. But the way I look at it is I looked at that previous one, it was like, holy smokes, like 66% in the sample were stopped and charged that were black people. And yet when we dug a little bit deeper, we saw that of the percentage of black people that were stopped and that were charged, it was actually lower than a couple of other races. Okay. That's sort of the main focus of this. Okay. That sort of takes care of this. So you want to be able to describe and you want to be able to answer questions from a two-way table. Okay. You want to be able to analyze a bar graph, possibly create one. And then you also want to talk about association. Is there association between the two categorical variables you're talking about? This is really important. Association does not mean causation. Okay? We'll talk about whether something causes something else later on. Like, so I believe the number every year, the percentage of students that take AP stats is increasing. And I also believe that that every year, the number of people that strangle themselves to death in their own bed with their sheets, which is something that actually happens, is also increasing. What does that mean? That means that if you take AP stats, there's a bigger chance that you're going to die in your bed. There's an association there, a weird one, but it doesn't mean that just because you take AP stats, it's going to cause a higher risk of, I can't remember what they call it. When you, but yeah, I know. You guys, everything's measured in life. Everything. Just go to Instagram or go to TikTok or whatever. So this just kind of, don't worry about taking notes along this. So here we have an advocate that went back to the data. Okay, this person is for stop and frisk. And they came up with this. They said, well, of all the people that's committed criminal offenses, so that was the margin total, 3684. 77 were Asian, only 2.1%. 2431 were black, 66%. 824 were Hispanic, 22.4%. 352 were white, 9.6%. Okay. Does this now go back to that mayor's claim that everything's taking place in all the crime is taking place in minority neighborhoods? Well, this seems to suggest that, just like that bar graph we had at the beginning seemed to suggest it, although when we studied it further, we found that no, that's not really the case. Okay? Can you see why? How would you argue against this?
the marginal rule that they're using,
Yes?
a higher percentage of Black people were stopped compared to the rest of the original groups.
Precisely. Okay? The percentage is higher because look at the grand total. Like, look at the number that were 6,196 out of 9,321. Almost like 2/3 that were stopped in the first place, whether they were charged or not, were Black. So naturally, this is going to be higher because so many of them were stopped compared to the other races. So to me, this doesn't really provide any compelling new evidence. This is kind of going back to the first graph, the first bar graph that I showed you, okay? The racial distribution of civilians stopped and charged was pretty much the same thing as these ones. But again, it's because so many, I mean, you could turn it around the other way. What about the ones that were not charged? If you did it the not charged, you'd get the same kind of thing. And the majority that were not charged would be Black people. And how does that make sense? They're the majority that are charged, and they're also the majority that are not charged, because so many Black people were stopped compared to the other three races. That's why. Okay, so that sort of takes care of that. You guys have this here. There should have been something I crossed off in the last assigned practice. You shouldn't have done number 7, because I'm sure it might have been confusing when you looked at it and saw discrete and continuous. Some of you are familiar with that, discrete and continuous, but we haven't really talked about it yet in this class, okay? We will talk about it a little bit later, so don't worry about number 7, just cross it out. Question number 7. In the practice where it says number 7, cross it out. We didn't talk about discrete and continuous data. I can't remember. I think it's things like distance from home and stuff like that. So